talk about stress. And not the kind you're experiencing just because you're in engineering school, but the kind that you're going to be working with because you're in engineering school. So this stress that we're going to be talking about is related to internal forces in a body, right? So if we have some body, some kind of blob like this, what it is it's a measure of intensity of the internal forces. So we'll take our little blob here, and if I were to chop it open, and I just kind of have my blob, but oops, cut its head off. So now I just have this little, I cut through here and I get this little blob thing. Then I'm going to see all of these forces pouring out, all of the forces that are going on within the body. Right? So the shear, the moment, the torsion, all of those internal forces I can see when I make that cut through my body. And we can draw a free body diagram for that and actually look and calculate these forces. But what a stress is just the intensity of these forces. So the way we see stress is typically in two forms. We see normal stress, and that comes from the normal force that we see coming out of this. And then we also see shear stress. Shear stress. So those are stresses caused by normal forces or by shear forces. And we're pretty familiar with those from doing all of our internal force calculations from statics. So these are the two that we're going to typically see. And what those look like, if I were to take maybe my beam here, and I were going to look at the cross section here on the end. So let's say I cut through a beam. Here's my end cross section. Let's look at this guy. If I draw this cross section out here, then what I'm going to see is my normal stress, which we're going to represent with the Greek letter sigma. That's a lowercase sigma. My normal stress acts normal to that plane, right? So it's pointing out away. It's perpendicular from these sides. So if this is in an XY plane, then this would be like my normal stress in the Y direction. Normal stress in the X direction, Y, X. So my normal stress, again, is perpendicular to the cross-sectional area. Perpendicular to the cross-sectional area, it's pointing out away from that, just like our normal force points out and away from this cross-section. The normal stress points out and away from those cross-sections. Now our shear stress, which we see represented by the lowercase tau, Greek letter tau, we see as acting tangent to the plane. So something maybe like this, we'll see these shear stresses tangent to this cross-sectional area that we're interested in. This is our area A, cross-sectional area here, which we expect, right? With the shear force acts something like this, up and down along the plane here, so this shear stress is also going to act in the same way. Shear tau, lowercase tau, shear stress. Something like that. So this is what we're looking at. These are the normal and shear stresses. The way we calculate these is typically by taking an average. This is what we're going to look at first, is the average normal stress on a cross-section and an average shear stress on a cross-section. So your average normal stress, your average normal stress is given by that normal force divided by the cross-sectional area. So this is our sigma normal stress equals the normal force over the cross-sectional area. And if we wanted to calculate the average shear stress, for this cross-sectional area. Here, that would be tau, is the shear V that we calculate from the beam divided by this cross-sectional area A. So these are the two equations that we're going to be starting out with. So if we look at our units for these guys, if I have a force over an area, the units that I'm going to end up with are going to be, of course, a force over an area, or a force measurement like newtons or pounds, and then the bottom is an area, so that's a distance squared. So we're often going to see newtons per meter squared, which is also the standard unit of a Pascal. Or we'll also see PSI, pounds per square inch, or even KSI, which is kips per square inch. These are the most common units that we see stress in. And if those units look familiar to you and you're like, wait, these are just the same equations for pressure. Well, you're right, they are the same equations for pressure. They're the same units as pressure. But stress is a little bit different from pressure in that pressure is something that acts externally on the body. Like you can think when you go underwater and you can feel the water pressing against you, that would be pressure. Whereas stress is something that comes from within the body. It is from the internal forces of the body, not from external forces. And it's also like a property of the material itself. Whereas pressure is some outside object or force acting on a body. This is internal. So that's really the major difference between stress and pressure. They have the same units, but they are different quantities, and we work with them in different ways.